Hello learners, welcome back to my YouTube channel. Previously, in Form 3, we were dealing with the chemistry of the gas law. We have done lesson 2 on the introduction side of the Charles law, where we were stating the law, knowing how to write, how to draw the graphs, implication, the molecular, and also the application side. So here, we are going to go to the application of the Charles law. So let's start the first question. A gas occupies 200 centimeter cube at 0 degrees Celsius and 740 millimeter mercury pressure. What volume will it occupy at 47 degrees Celsius at the same pressure? Remember what you have said on Charles law? Charles law states that the volume of fixed mass of a gas is directly proportional to its absolute temperature at a constant pressure. So pressure is constant. That means we are not going to use it in calculation. After that, let's just try to have our values on that volume and also absolute temperature. So volume 1. What's our volume 1? Our volume 1 is 200 centimeter cube. Next, our temperature 1. Our temperature 1 here is degree Celsius, but we are supposed to convert this degree Celsius into Kelvin scale. So we are supposed to add plus 273. So here we are going to get 273 Kelvin. So what do you have as your volume 2? We don't have, because we are told what volume. So here we have question mark. Then temperature 2, we are told, will it occupy at 47 degrees Celsius? So we have 47 degrees Celsius, but to convert it into the Kelvin scale, we are supposed to add plus 273. So what are we going to get? When we take 47, then we add 273. So we have 47 plus 273. So we're having 320. So we're having 320 Kelvin. So thereafter, students, what is our formula for calculating the Charles law? The formula for calculating Charles law was V1 T2, which is equal to V2 T1. So what do you have as your volume 1? 200 times temperature 2, that's 320, which will be equal to volume 2, which we don't have, times temperature 1, which is 273 Kelvin. So to get volume 2, we divide here by 273, then we divide 273. That means volume 2 will be, so 273 will go with 273. So we're having 200 plus 320 divided by 273. So our answer there is, let me repeat, 200 times 320 divided by 273. So we are going to get 234.4 centimeter cube. The volume here was in centimeter cube. So learners, you can confirm whether you are correct or not by just remembering what the law states. We are told, what the law implies. We are told volume is directly proportional to the absolute temperature. So check the volume, you are having 200. Okay, so the first temperature here we are having 273, then second we are having 320. That means there was an increase in the absolute temperature, therefore we expect an increase on the side of the volume. So volume 2 is 234.4, which is bigger than our volume 1. So let's go to example 2. Example 2, we are told at a temperature of 57 degrees Celsius, nitrogen gas occupies a volume of 750 centimeter cube. At what temperature will the gas occupy 100 centimeter cube? You express your answer. I'm at the answer in degrees Celsius. Okay, first of all, let's get our values again. V1. What's your volume 1? 750 centimeter cube. What is your temperature 1? It is 57 degrees Celsius. But to convert into the Kelvin scale, you are supposed to add 273. So what is 57 plus 273? We are going to get 330 Kelvin. 330 Kelvin. So volume 2 here, we are given 100 centimeter cube. 100 centimeter cube. So temperature 2, we don't have. So after that, remember the formula. Remember the formula for Charles law. V1 T2 is equal to V2 T1. So here our volume 1 is 750 times temperature 2, which you don't have, which will be equal to volume 2, which you have 100 times temperature 1, which is 330 Kelvin. So to get temperature 2, we divide here by 750 and the other side 750. So temperature 2, what are we going to get? So we're having 100 times 330 equal divided by 750. We are going to get 44. So the unit here is Kelvin. So you are told express your answer in degree Celsius. So how will you convert Kelvin scale to degree Celsius? By subtracting 273 from the answer you have. So 44 minus 273, what we are going to get will be negative 229 degree Celsius. That's for that question number 2. Learners, I hope you are going with me. Number 3, you are told a balloon contains 100 centimeter cube of air at 25 degrees Celsius. The balloon was put outside in the sun where the temperature was 40 degrees Celsius. So calculate the new volume of the air in the balloon. So we have again our values. What do you have as your volume 1? 100 centimeter cube. So what about your temperature 1? Temperature 1 is 25 degrees Celsius, but you are supposed to convert that one into the Kelvin scale. Learners, you are supposed to convert all gas law conditions for temperature must be in Kelvin. So we are having 25 plus 273. We are having 298 Kelvin. So what about volume 2? We don't have volume 2 because we are told calculate the new volume. So what about temperature 2? Our temperature 2 is 40 degrees Celsius. So 40 degrees Celsius to convert into Kelvin, you are supposed to add plus 273. So what about 40 plus 273? So 40 plus 273, we're having 313 Kelvin. So let's remember the formula for Charles' law. Let's use the other way around. V1 over T1 will be equal to V2 over T2. So what's your volume 1? It's 100 over T1, which is 298, which will be equal to volume 2, which you don't have, over temperature 2, which you have 313. Cross multiply. We are going to get 298 times volume 2 will be equal to 100 times 313. If you want to get V2, we divide it by 298, then 298. So volume 2 here, we are going to get 100 times 313 answer divided by 298. What are we going to get? We are going to get 105.0. So that's 105 centimeter cube. So learners, you can know whether your answer is correct or not by just checking now the side of the absolute temperature. The absolute temperature has increased. That means the volume is also expected to increase, because we said volume increases, pressure also increases. If pressure increases, the volume on the other side also increases. So after that, learners, let's go to the extended question. We have only one question for you. Try to answer it, and I'm going to confirm it, your response or your answers on the comment section. So goodbye. Let's meet on our next class as we look on the combined gas law, inshallah. Thank you. Goodbye.